Welcome to EE World. I'm Senior Technical Editor Martin Rowe. Well, we're 5 years or so into 5G, and if you talk to the telecom pundits and analysts, 5G has been a flop, at least from a consumer perspective. Nobody wants to pay for service that's only slightly faster than what we get from LTE, and nobody wants to really use more battery power, as I discovered when I ran some tests. Before the first 5G standard was released, the telecom industry was actually talking about use cases and technologies such as private networks, network slicing, machine-to-machine communications, low latency, and so on. These applications are starting to come, but because they're business applications and not consumer applications, businesses take a lot longer to adopt new technology than consumers. So these things are taking time, and nobody wants to wait anymore because the telecom carriers haven't really made any money off of 5G. And they might make money off of it with all these industrial applications, but that hasn't happened yet. So what we're going to look at is 5G and 6G. Many things about 6G have been talked about, such as lower energy consumption, sustainability, higher speeds, and so on. And given that we tend to run in a 10-year cycle, getting to the next G, we're already halfway through or close to halfway through this decade. And so there's talk about 6G being ready to come to a standard around the end of the decade, just as 5G did at the end of the previous decade. So recently, I was approached by Matsing to say, we need to put the brakes on and focus a little bit more on 5G than on 6G. And based on that, we're going to discuss this topic with Matsing's Manish Mehta and with Keysight's Roger Nichols. At Keysight, Roger is the manager of the 6G program, so he's been involved in a lot in this research now for several years. So, Manish, let's start with you. What is it that you see or think we need to do differently? Do we need to focus more on 5G advanced and slow down 6G, or should 6G, in your opinion, continue at whatever pace it's going at?
So thanks a lot, Martin. And hello, Roger. Look, I think the pace is what it is. I mean, the standards will be set in place in the next coming, months, years, and then we will have the release of 6G and the investments will begin. The point is while 6G deployment will happen, the life of 5G is much beyond the 10 years that's typical for any generation that we've seen. And the reason is very simple. What 5G enables today, the capabilities that it enables, and the network capabilities that it enables, that really needs to be focused on. And with 5G advanced coming in, a lot of the speed, the latency, the energy consumption, all of those benefits will be quadrupled actually, in this in the coming years. So with that said, the life of 5G needs to be looked at not as a product, but more as a continuum, because we'll see that extending. And what we are talking about is 5G in some parts of the world is just being launched. So we may be at 5 years in the US, but in a lot of other parts of the world, 5G is just being launched. So we have to look at it from a whole global perspective.
As we know, generations don't just go away after 10 years, as soon as the next one comes out. 3G is now just being phased out.
Yes.
2G is continuing in some parts of the world that don't have anything else. So I think that with all of the other things that are beyond cell phones that are being built into 5G, that it's going to have an even longer life cycle, especially with these industrial applications. Roger, what do you think about that?
The life cycle will extend into the next decade with 5G, particularly because if you think about 5G Advanced, which I believe, if I have this right, is release 18 and beyond, uh, release 18 is really not in commercial deployment yet. And so, I mean, it's just too recent for that to become manifest in the industry. And all of the capabilities in Release 18, and to be honest, the capabilities that make true 5G, which include, working and pervasive standalone networks, they're not pervasive yet. And a standalone network is kind of necessary to take advantage of the way that 5G was originally envisioned. So as that rolls out, I think we'll see the broader use for 5G extend. And when I say broader use, I mean outside of the EMBB context, beyond those of us using smartphones and YouTube and that kind of thing. The other thing I'll highlight is that I don't think this is new. There's still significant 2G only implementations in the world. It's been around for a long time. And the next thing I'd highlight is that what really gave the mobile internet a boost in previous decades, a significant boost, was the launch of Edge, the evolved GPRS packet data radio, which Edge was launched as a 2G solution 2 years after 3G was first launched. And Edge breathed a significant amount of life into the early form of the mobile internet. And so, it isn't new for these things to continue. And a lot of that is the operators in particular are going to do everything they can to squeeze value out of the investment they've already made. And I think we're gonna see that continue. I don't think that's new.
One of the things that we were supposed to get was millimeter wave. And that has turned out, at least from the telecom pundits' perspective, to be a flop, primarily, I think at least, because the carriers found that implementing it is quite expensive. To try to put a small cell on every street light is very expensive. And so it hasn't been done in a lot of places, to my knowledge. And so given that the super high speeds that were promised never happened, and therefore because of that, I think that's why the telecom carriers haven't made any money, because 5G isn't much faster than 4G. Having said that, we are starting to see some of these industrial applications, and some of them were actually demonstrated quite early. But we are hearing more and more about private networks and network slicing, things like that. I'll go back to Manish and then to Roger. What have you seen in terms of these other applications? Do you see them starting to ramp up? Given, I think that it will probably take several years before we really see widespread implementation.
Yeah, so let's take them, one by one. So and I'll try to do that in a concise manner. 5G, when you look at 5G as a technology and you look at private networks, I mean, the premise of private networks is you are giving people a secure, you're providing mobility, and you're providing assurance in the network, and then giving them capabilities around it. And the capabilities enable automation, the capabilities enable, communication within and outside boundaries. But at the end of the day, what's the premise of private networks is the ownership relies on the enterprise, and that's a big paradigm shift. And enterprises are not experts in telecom traditionally, so carriers are involved. So now you get into the MORAN and the MOCN and so on, architecture that comes into play. Now you bring that down into what's practical. Absolutely, I mean, private 5G definitely has a place in the future. And but the future is long. It's not. We cannot look at that in a couple of years. We have to look at that in multiple years, because and even decades, because these are complex, technologies that are being deployed. And not just that, the capabilities that are being enabled are, in some ways enhancing human work, but it's also replacing in some ways. So there is a lot that really happens. Now with 5G Advanced coming in, you're going to get precise location. So you're going to get less than 10 centimeter of location accuracy. That's going to be huge when it comes to automation. That's going to be huge when it comes to public safety, getting people at the right spot in the right area of need. So those things truly will start pushing the need to deploy private 5G, and that goes beyond replacing Wi-Fi, because I don't think that's the issue. The issue is not replacing Wi-Fi, but bringing in the complexity into the hands of the enterprise with the help of the carriers and the others that are 3POs and the integrators that have to be involved in this whole process. Now, when it comes to 5G standalone, that's that's enabling various capabilities, and the primary thing is that you're going to get the spectrum to be maximized. So the use of the spectrum can be maximized, so that should be able to provide you lanes for the spectrum to be deployed that will be freeing up for enterprise applications.
Roger, what do you think?
Well, let me touch just briefly on your FR2 comment and millimeter wave. So absolutely, this is more expensive to deploy, both in the infrastructure and in the devices. And what I think somebody was telling me yesterday, practically speaking, nobody, your typical cell phone user, your typical smartphone user never uses nor really needs anything more than about 50 megabits per second. That seems to be good enough for most of what we do. And so these super fast speeds fundamentally are expensive without a tremendous amount of demand. And I think that will change. I believe the next phase of, God knows, XR, game development, whatever, is going to drive more demand for that kind of speed and brute force latency resolution. And we're going to see that continue to grow, which will help drive down the cost based on scale. I just think it's going to take time. It turns out that industrial applications are one area where that can be fairly handy, where you have small cell, short distance, very high demand in bandwidth. So if we get then into the private network space, I think we have a few things we have to deal with. One of those is scale. If you're going to own a private network, you have to be a big enough enterprise to afford it, and it's a pretty big investment. We could do slices for smaller enterprises, and that may help. But of course, slices require a robust standalone situation, and overcoming a lot of the fears about am I really going to get the performance that I pay for in my slice for my SLA that I put together with whomever is doing that. The other thing is that, as Manish mentioned, when you bring in a 5G system to an industrial application, regardless of the industry, you have to merge operating technology with information technology, and all of the IT specialists, I shouldn't say that, most of the IT specialists in enterprise are not cellular experts, right? They've done IT a different way, and they're having to come up to speed in a new set of technologies, and that just takes time. I spoke to a gentleman who works for a large concrete manufacturing company in the Midwest, and he is their telecoms expert. And they have deployed 5G in their the gravel pits and that sort of thing, where they actually get the aggregate. It's a fascinating conversation. He said quite literally that 5G is far more reliable than 4G, and definitely both are better than Wi-Fi. They still struggle with how to manage coverage, but they're pretty much all in terms of using mobile technology in a private network to help manage what they do. And I think this is a good example of a very traditional, pre-conservative industry that is adopting new technology. And as Manish said, this is gonna happen. It's just going to take time. And he talked about the issues that they had. And I think the other one is greenfield versus brownfield implementation. If you have a factory or any kind of logistic enterprise or whatever that is running smoothly, and you want to change the IT system and put in, wireless network or whatever, the break-even time has to be pretty short in order to justify a brownfield implementation. It's already up and running. Why would I bother with this kind of thing? And I think that's another reason why it takes time. In a lot of cases, it's too difficult to justify the investment, and versus a greenfield implementation where you're building something from scratch, which has a higher likelihood of happening. But because you're building it from scratch, these large scale implementations are just going to take time. And I believe it will happen. I think the flexibility in 5G is great. I think the papers I've read recently suggest that the complexity is too high, and that is a sort of new objective that is being put in front of the 6G researchers, which is to make this simpler to use for the sake of bringing on the parts of the industry that are not EMBB users.
Well, you mentioned 6G, so I'll switch over to that a little bit. Roger, you've been at 6G conferences for a number of years, as have I. Manish, I don't know if you have been, but or at least I've never met you there, but hopefully that will change soon.
It will.
Okay, very, very good. And what we've heard about what 6G might be seems to change with every year's conference. One year we heard a lot of talk about we must lower energy consumption. That was a big deal. Haven't heard much about that in 2 years. Things seem to be shifting more to how are we going to use the next technology to make money for the carriers. Another thing we heard something about a capability is integrated communications and sensing, that not just being distance, but being able to identify, an object or a person. And that may need, we at millimeter wave or sub-terahertz, I'm not sure. But so there's talk of that. So I'll start with Roger in this case. Roger, what are you hearing in terms of where is 6G going, and what do you see as the priorities that are emerging?
Well, the first thing I would say in terms of 6G is some people would say, well, why are we investing at all? And my perspective on this is we need to look at a generational change. Maybe it's not, a big compatibility break from like 5G was from 4G. But we need to look at a generational change to take advantage of advancement in the technology, because that advancement is inexorable, right? We continue that process. So that's kind of number one. But where I see things headed is in the last year, and we've talked about this, is the emphasis is moving to be more, the term I like to use is evolution heavy and revolution light. And that's really probably no more well stated than in the NGMN position paper, where as a group of operators, mostly they're saying, look, it doesn't make sense for us to invest in this unless a path to growth is pretty clear. And that growth isn't going to happen if the investment is really high and the pain of change is really high. So we have to make real some of the vision that we originally put together for 5G. And so I think what that means is an emphasis on carrier revenue growth opportunity. And a lot of that comes not from adding more users using high video content kinds of situations, although potentially the XR component could be part of that. But it comes from expanding into more vertical industries. And we just talked about the private network space. And one of the other lessons learned that's come up in the 5G space in the conversations, and you've heard these, Martin, is that 5G was developed with the confidence that if we made a more flexible network, we could expand into other vertical industries. But I think the recognition is that the telecoms industry did not involve the vertical industries as much as they needed to in defining what 5G would be and how it might be used. And the intent here is changing. There was a workshop, I think just last week in Taiwan, right after the RAN meetings that were actually in Shanghai, but I think the workshop was in Taiwan. And there were some presentations that described this very clearly in terms of what it was going to take to ensure that we had capabilities that were going to be leverageable by the broader set of enterprise, the other vertical businesses, which means a growth in the business, right? That's the opportunity for the operators, is to sell solutions and capabilities that go beyond the current user base. And that's a big piece of the growth. And of course, it has to be not super expensive to implement, or if it is, the net present value has to be pretty clear. And I think that's the way things tend to be moving in the 6G space.
Manish?
I agree with Roger 100%. I mean, but let me just bring a couple of examples here, which may make sense. We at Matsing, we focus, on high capacity connectivity, as you know, and we enable that from the last mile perspective. So the last mile being from the antenna onto the user, we are providing high capacity connectivity. So what we are doing now is venues like stadiums and arenas. Those could be really good use case for 6G implementation, just like millimeter wave is in certain areas of the venue. Like the premium seating, they have some millimeter wave. But in general, when you're looking at the overall stadium and you have 80,000 people sitting, what the carriers are doing now is beginning to deploy C-band. And C-band, as you know, is the 3.7 to 3.98 gigahertz spectrum, high capacity. It's a good blend of capacity coverage. And that's just beginning to be deployed. I mean, there are only a handful of stadiums today that have been deployed, and the focus on C-band has been for over 2 years. So when you look at this whole cycle of deployment, it takes time. There is a budget involved, but it's not just budget. There are so many things that are involved. Is it peak season? Is it season time? You cannot do anything during the season, so you have to do it off season. You have to line up everything to deploy. So there is a lot of complexity when it comes to operations and so on. It's not just about the technology. It's about being able to to implement. Now, C-band is huge, but we are only in the infancy of C-band. So this has to play out. But 6G could be a very good use case in certain areas within high capacity venues like stadiums and arenas, because what 6G, if we know what it's going to be AI driven quite a bit, right? So there'll be a lot of AI aspects to it. Now we're trying to bring some of that in AI into our RAN today. We are trying to bring AI into customer experience. We are trying to bring AI into how the antennas in some ways can be remotely tilted and so on, that can take care of high capacity requirements within venues. Now, is that truly the step towards 6G? Maybe it is, but we are too early on to say exactly what 6G is going to be. But I think use cases like high traffic venues, like sports venues, that could be one of them.
Well, I'm glad you brought up AI. I was going to do that, and I will do that. But just before we swing back to AI, I wanted to spend a minute talking about FR3. Now, FR3, which is somewhat undefined, it's somewhere between 7 gigahertz and 24 gigahertz, the so-called FR2. I was recently at the IEEE Microwave Symposium, and where years ago there was lots of talk about 5G radios, there's no talk about that at all, simply because the radios are defined, and so they've moved on. But there were some demonstrations about FR3, and I wanted to see if is FR3 a 6G thing? Might it be implemented in 5G? Might it not be implemented at all? Obviously, this is going to take some regulatory input for the carriers to be able to use that, whether they get any slices of the band dedicated to cellular or whether there's some form of spectrum sharing. So what do you see about FR3, and is it going to be a reality or not, or maybe not? Roger, you want to start with that?
So a couple of things on this. This 7 to 24 gigahertz territory, with probably more focus on the lower half of that than the upper half, at least right now. And that gets back to the cost and complexity of implementing things in the higher frequencies, is getting a huge amount of attention, both in the regulatory space and in the research space that I see as well. You could look at a report that the CTIA commissioned a year and a half ago or so that effectively says we need to add 2 gigahertz of additional spectrum to the cellular business to maintain demand, to maintain capacity that will meet the demand that is coming for just more data, which is growing at about a 20% CAGR for the next 8 or 9 years. And now it's 150 exabytes per month worldwide. So those numbers are huge, and they're growing faster. It'll be 450 in the next few years. So the key is the way that capacity demand is going to be met, if it continues, it can only involve, to some extent, the addition of new spectrum. Now, do we need 2 full gigahertz of new spectrum? That's an argument that will go on for a long time. In the U.S., the FCC has a proposed rule about opening up 12.75 to 13.2 gigahertz for IMT. And that's been a proposed rule for a couple of years, and I'm sure it's still getting quite a bit of discussion. Outside of the US, in Korea and Japan, they're actively looking at expanding capabilities in this area between 7 and 24. A lot of the regulators in Europe are openly opposed to opening up new spectrum in that space. So it's a regulatory challenge. It's already an issue with incumbency, and it's all chopped up. A lot of it in the US, for example, is set aside for federal use. So I think, as you said, there's a regulatory issue that will exist, but I also think that the demand for moving spectrum for an industry that is growing this fast and has this much potential and ultimately use by society, I think they will open up spectrum in this area to be used as the next several years advance. Are they going to use it for 5G and or 6G? One of the lessons we learned in 5G is if you have a new air interface, it is extremely difficult to implement that in spectrum that is already being used at a reasonable demand. So that's why the 3.5 or 3.7 gigahertz areas were set aside as greenfield spectrum for 5G and pretty successful. Whereas the spectrum sharing that had to be implemented when you had to use spectrum that was already being consumed by LTE was very painful and continues to be. So, my perspective on this is that if and when the FR3 spectrum is opened up by regulators, it will, in many cases, first be occupied by new technologies, and then gradually they'll expand, NR capability into that. And a lot of that will have to do with how compatible they make these air interfaces in the standards, which turns out to look like a pretty big priority, especially looking at the presentations from some of the companies at this workshop that the Taiwan standards body held last week.
Okay, well, we're getting a little short on time, so let's go back to Manish, because you had started to talk about AI, and let's make this our last topic. So, Manish, would you like to expand a little bit on how you see AI playing a role in telecom?
So yeah, I mean, again, AI customer service perspective has been around in not an AI form, but in other forms. We started calling it AI in the recent past, but really carriers and, I would say operators in general have kind of looked at customer service as the first entry, to make sure that, not only do you serve the customers, but you also bring some of the cost, savings, into play. Then when the guts of it all comes down to the RAN optimization, and how do you optimize the RAN? How do you provide data analytics? Those are things that are happening as we speak. Where AI is driving a lot of the analytics. Around the network itself, the performance of the network. How the network data can be crunched better, and the usage rates, and the peak rates, peak usage, all of that is numbers that need to be crunched and put through the system. So that's happening from an AI perspective, and that's usually beneficial. And the other part that I would say is fraud detection, security. Those are highly AI, going to be highly AI driven in the coming years. Then there is a whole body that's working on the standards body that's working on 6G, where AI will be incorporated more. But all of the things that we see today, from a RAN optimization, from a data security, fraud detection, from customer service, all of those are leading up to what 6G will truly deliver from a AI perspective.
Roger, last word is yours.
Yeah, just real quick. It's been AI, and when I say AI, let's talk about specifically machine learning, which I will define as artificial intelligence implemented in models that are trained neural networks, right? I mean, let's talk about that specific piece of it. That's been in use for a while already in cellular, in typically a proprietary environment, doing things like MIMO pre-coding, even cell or network planning, that kind of things. So very, very complex topics with lots of variables. So that's already in use and has been for a while. Now, though, it's being written into the standards in Release 19 with normative work going on in 3GPP for the air interface in just a few key areas. And I think that will continue to evolve with the intent, which was put together for 6G at the very beginning back in 2018 when the ITU was looking at this to build AI capabilities for network optimization into 6G from the ground up, rather than it being an add-on in 5G. And I agree with Manish. It's about network optimization. For us, it has less to do with large language models, which is what's getting all the hype, and more to do with technical optimization of these terribly complex problems that cannot be solved with a closed form deterministic mathematical solution. And so expanding capabilities in MIMO, traffic control, probably even used in scheduling, but that won't be standardized, right? That'll be proprietary. And we're going to learn where it's going to work well and where it will not work well over the next few years as the research progresses. I'm pretty excited about being part of this. And I think we're in for some surprises, both positive and negative. But that's part of what this is all about. And I think AI is going to provide some significant benefits for us.
Manish Mehta of Matsing, Roger Nichols of Keysight, thank you for this interesting discussion on 5G, where it's going, where it should be going, 6G, where it's going, where it should be going. For EE World, I'm Senior Technical Editor Martin Rowe. Thank you for watching.